This is Alex from CloudRF here with a demonstration of solving the pizza problem using machine learning. The pizza problem is when you have collected measurements of a signal and you can only see a slice of the pizza, but you would like to see the whole pizza. In this case, the site that we're surveying is an LTE cell on an airfield right here. We have measurements over to the east, but only a few. And this is quite a common scenario that you don't have the luxury of having comprehensive measurements all around a cell because that requires an incredible amount of time and fuel and man hours. So we just have some measurements and we need to make do. We've loaded the measurements from an app called RantCell, and this is the output of the app. It's very rich GPS accurate data containing RSRP measurements which we've put onto here. And with these measurements we can do calibration. So loading in the data for the calibration utility, we could go and manipulate our environment in order to achieve a match. Now that's great if you're comfortable doing that and you have the time. If you don't, do auto calibration. So auto calibration uses a script and it automates the process. In this case, we're taking in the same spreadsheet, throwing it at a soothsayer server just to save time and knock off the rate limiting. And with this script, we're able to do a genetic algorithm. I'll just run the script and then we'll talk about it. What's happening is it's processing 9 random iterations within bounded parameters with each run. And at the end of a run, the winners will be selected as the parents to move on to breed the next generation and so on. And you can decide how many times you want to run this. So let's let that script run, and while it's running, if you have a look in the soothsayer archive, you can see that we've already done 10, and if I open it up, we've now done 12. So it's working through the calculations quite quickly using an A4000 GPU and some data that's on a HP G2 desktop. The scores are very good, but we have only got limited measurements here, so we'd expect them to be quite good. But many of the measurements are non-line of sight, so we're having to deal with clutter. And when we're talking clutter here, we're talking the buildings and the trees between us and the transmitter. And what we're doing with this script is we're asking the script to find us the nominal attenuation for the buildings, the trees, and also the tree height. I know we can look at satellite imagery and all make a good guess at what the tree heights are, but the tree species vary, and we're looking for a nominal height for all the trees that will work for our modeling for this area. So we're nearly done now. We're on generation 3 and the score's excellent. The trees are 10 meters tall, and here are the coefficients that we need in order to calibrate the modeling. So that's the work done there, and I can go now to CloudRF. I've got my site set up here. I already know the frequency and the tower height, so now I can go and just fine-tune it with the values from the process. So there's my custom template, Swindon, and I'm going to enter a 0.13 for the building attenuation, 10 for the trees, and finally 0.035 for the tree attenuation. Let's give that a go and see what we get. So 5 meter resolution, 3 kilometer radius. We're using a color key here versus what's on Soothsayer with a grayscale. I'll just show you the Soothsayer one. The reason it's doing grayscale is because that's accurate to 1 decibel and it's meant for machines and scripts, not for humans. So this is pretty heat maps obviously for humans, and we're really happy with the score here. It's one of the best we've ever seen. And let's go and open up the resolution. So 10 meter resolution, 10 kilometers, why not? And we'll go and see the whole pizza. So that's the pizza problem solved using machine learning.